Now we're going to get a formula for the area of a circle by dissecting it, chopping it up and rearranging the pieces. So we're going to start cutting them into wedges that are smaller and smaller, but not quite cut apart. So we're going to have them all hanging together. So first we want to make a right angle cut that makes each half circle into a quarter circle. And I'm just using the corner of a little piece of card. If you have a small enough circle, maybe you can eyeball this pretty well. So I'm going to cut not quite to the edge, as close as you can get, but if you... Whew, that was really close. That was a little too close. There. Now we can actually take these two pieces and wedge them together, alternating up and down wedges like that. And we get another shape that still doesn't look like we know how to find the area of it. Okay, so just going to repeat. If you have a pretty big circle, you may want to fold a piece of paper to make a 45-degree angle to get the cut that cuts this sector in half. And if you have a pretty small one, maybe eyeballing it will be good enough. Do that to each of your pieces. And once they're done, put them together kind of like teeth, alternating. So one from the left, one from the right, and so on. And because they're made of foam, they should kind of stick together. Maybe it's easier to put them down there. That works pretty nicely. There. So it's starting to look a little bit like a parallelogram. So do it one more time. Cut each sector in half, not quite to the edge, and then stick them together so you get something like a parallelogram. So pause the video while you do that. So I've pre-made one that has the next stage finished. This one happens to be brown. So here's one part. Here's the other part. And they'll fit together to make something that's pretty much like a parallelogram, and it even starts to look a little like a rectangle. So in fact, if you could do it even one more time, the applet that I will show you in a bit goes for so many steps that it really does look like the ends are vertical. You could imagine cutting half of the last one on, putting it over here to make it really into a rectangle. And the edges are a little bit curved, but they're starting to straighten out quite a lot. So you can imagine that if you did this one more step, it would really look quite a lot like a rectangle. So because it's the same pieces, the area of this parallelogram or rectangle is the same as the area of the original circle. And we do have a formula for the area of a rectangle, which is base times height. Also works for parallelograms. So the height has to be measured perpendicular to the base. Okay, and instead of measuring it with a ruler, let's just figure out what it has to do with the original circle. So what is the base on the original circle? Well, take it back apart. Oh, it was half the circumference. And the base on the top was the other half of the circumference. How about the height of this rectangle? Well, that's the distance from this pointy edge all the way to the top, which was, the pointy edge was right at the center of the circle. The distance from the center of the circle to the edge is the radius of the circle. So what we have here is a rectangle whose base is half the circumference of a circle and whose height is the radius of the circle. And it has the same area as the circle. Let's go back to the number line. So this isn't going to be quite right because, see, this pointy part should go all the way to the top, and because we didn't really cut all the way through, it doesn't. So it's going to be taller than it really should be, and it's going to be a little shorter than it should be. But you can kind of believe that here we have, it goes on the number line up to 1/2 the circumference, as we said from reasoning, and the height should be the radius in height. Well, the radius we had chosen, well, I had chosen 6 graph paper units, so I could just mark that vertically. 1, 2, 3, 4, 5, 6. So I'm drawing another rectangle that has the dimensions that we figured out. So there's a radius and height. Same over here. 1, 2, 3, 4, 5, 6, or whatever your radius was. Okay, so there's a rectangle that has the same area as the circle. So the final step is to break it into squares, radius squares. So because here's 1 radius wide, here's 1 radius high, so I can make an r squared. Here's another r squared. Here's a third r squared. Oh, and there's a little more. Okay, so here's r squared. Here's r squared. Here's r squared, plus a little extra. So how many r squareds was that? Well, a little more than 3, exactly pi, because that's how many radii it took to get to 1/2 the circumference. So that gives you another formula. The area of a circle equals pi r squareds. So you should read that as r squared is a square whose side is r, and pi is how many of them, and it's a little more than 3. So this picture should remind you that the area of a circle is 3r squareds plus a little more. Oh, exactly, pi r squared is the area. Another reason that you can remember its area is because area is measured in squares. There's a square.